All right, so today we're going to look at 7-3. We're going to spend 2 days on 7-3. We're going to use what's called Gaussian elimination. And you're going to write yourself a lot of notes. So here we go. So if I were you, I would put over here. This is kind of the process that we're going to go by. And it's kind of a hit and miss little thing. So here's some suggestions. Suggestion 1. We can interchange two equations. Does that look fuzzy to you? Okay. Well, at least you're being honest with me. My freshmen, oh, is that better? Okay, because my freshmen are like, no, that's fine. I'm like, really? I can't be that blind. All right, so you can interchange two equations, or you could multiply one equation by a non-zero constant. I'm not sure that any of you would try to multiply an equation with 0. So that should be understood. And then a third way would be to add a multiple of one equation to another equation. So you're going to use one or more of these. Some of you did, some of you didn't. Yes. Well, we'll talk about that. Okay, he wants to know, can I use elimination for the first two and then substitution? Yes, but I'm going to give you kind of a path to follow. Yes, you use a combination of different things, and you've got to do them correctly. So you're going to use one or more of these methods. Right. Your goal is row echelon form. And I'm sure, have you heard of that?
Nope. That's easy.
Pardon?
Don't just write it like XYZ.
Sort of. I'm not sure what you mean by that, but maybe. So row echelon form, whoops, that's an F. And basically it looks like a stair-step pattern with leading coefficients of 1. So if you mean XYZ, meaning you get 1x, 1y, and 1z, yes, that's our goal. Is to get rid of the coefficients in one equation's x, get rid of the coefficient in one equation's y, and in one equation z. But you also have to get rid of the other variables. Okay, so these are the processes that we're going to make, and remember our goal is row echelon form. It just looks like a stair step. So in other words, maybe I want this whole first equation, see how it has a coefficient of 1 for that x. But then on the second equation, I just want it to have a 3y, and this one isn't going to have a z. Well, it might have a z when we're done with it, actually. Because I have to get rid of that x. And then I want this 3y to become a 1y. And then down here, I want to get rid of the x and the y and just have a z. So it'll be x, y, z in a stair-step form. Okay, so step 1. Since equation number 1, and I'm going to call this number 1, number 2, and number 3. Since equation number 1 has x, in other words, it's just 1x, coefficient of 1, eliminate any x terms. in the other equations. So that's my first goal. I'm going to keep this x, but I'm going to eliminate this x and that x. That's my first goal. So can't I take these two equations and add them together? Just the first and the second one? Don't my x's cancel out automatically using elimination, as Danny said, right? So I'm going to take x minus 2y plus 3z equals 9. I'm going to add to it negative x plus 3y equals negative 4. So my x's cancel, and I end up with a negative 2y and a positive 3y is just a y, plus 3z is equal to positive 5. Glory be, my y actually has a coefficient of 1. Nice. This is going to be my second equation, by the way. This is my first equation now. This is going to become my second equation. But I still have to eliminate the x in the third equation. So step 2, or note 2, this results pardon? That's number 1. So this results in a new equation that has a y and no x term, which is what we want. Remember, these are notes to yourself, because when you go home tonight, you're going to forget what we did. Trust me. Well, you have the video, right? All right, step 3, or note 3. If I want to eliminate this 2x, I'm still going to use the first equation right here. So what do I multiply the first equation by to get rid of the x term? Negative 2. So multiplying equation 1, number 1, by negative 2, and adding it to equation 3, we'll eliminate the x, term in equation number 3. So that's our purpose for doing that, and that's why you're writing yourself that note. So let's go ahead and do that. So I'm going to take, so I'll wait till you write it down first. Because I'm looking at the first and the second equation, I want to get rid of my x's. Remember, my first goal is to get rid of all the x's in all the equations but 1. So we're keeping the first one because it's got a coefficient of 1. And we're going to get rid of those 2 x's. And so to get rid of that x, I'm going to always combine it with that 1 I'm keeping. And so I'm going to multiply this equation by negative 2, so those will eliminate. Okay? So I'm going to take negative 2, I'm going to multiply it to the first equation, which is x minus 2y plus 3z equals 9. Draw a line underneath that because we're going to create a new system. So I get negative 2x plus 4y minus 6z equals negative 18. So that's my new one, right? Then I need to place the third equation right underneath that. Esther, if you need to move up so you can see, feel free. I know I'm writing small today. So then I'm going to write the third equation right underneath this and create a system, right? So I've got 2x minus 5y plus 5z equals 17. This is the new equation 1. This is the equation 3 that I did not change. The reason why I changed it was so that I could eliminate the x's, right? And so I'm left with 4 and negative 5y is negative y. Negative 6z and positive 5z is negative z equals negative 1. So let's just write what we currently have in equations. Because we've kept the first equation. We've changed the second equation to this, right? So this is your new second equation, new number 2. And then this is our third equation, but we're not going to keep this one because we don't want the y there, we want to get the z there. But we're just going to write what we currently have. So step 4, or note 4, you now have. So our first equation is still x minus 2y plus 3z equals 9. My new second equation is y plus 3z equals 5. And then this one we just had is negative y minus z equals negative 1. So see how I'm almost stair-stepped all the way? I'm stair-stepped from here to here, but now I have to get rid of this one. How do you propose we do that? Look at what you currently have. Yeah, can't you add 2 and 3 together? So now we're using elimination again. So then go up here to 5. You're going to write yourself kind of a lengthy note 5, because again, you're going to forget why you did this. So now, all but the first x has been eliminated. From the first column. Bless you. Bless you. Go to work on the second column. You need to eliminate the negative y from equation number 3 period. And so we decided that we're going to add the new, but I'm not going to write that in here, add equation number 2 and number 3. So we're adding the new number 2 and the new number 3 together. So rewrite that. So we've got y plus 3z equals 5, and negative y minus z equals negative 1. So you're going to have to kill a tree tonight in your homework. Please use a lot of room. You might want to number your steps as you go so you don't confuse yourself. The more you write, the less likely you are to get lost in your work. So then if I add that system together, my y's cancel out, and I'm left with 2z is equal to 4. What do I really want for my third equation? Because this is my third equation I'm working on. I want a coefficient of 1. So how do I manipulate this to get a coefficient of 1? Yeah, so 6. Now all you need is a coefficient of 1 in front of the z. You can either multiply by a half or divide by 2, right? So if I divide by 2, I'm just taking 2z equals 4 and I'm dividing it by 2, then I get z is equal to 2. So now I finally have my stair step. So, gotta write small. I've got 3 more comments to go. So step 7, now you have, so let's write what I have. We're keeping the first equation exactly as it was originally. X minus 2y plus 3z equals 9. Then we're keeping the second equation right here that we came up with. Y plus 3z is equal to 5. And this is our new third equation here. Z is equal to 2. What can I do from there? We've actually solved for z, right? Plug it in. Plug it in where? This one here. You don't want to plug it in up here because you've got 3 unknowns. But here I've got 2 unknowns, and I now know that z is 2. So step 8, put here. We're going to take y plus 3 and replace the 2. Could you do this in your head on your paper? Yes, but these are your notes, so write it down. We have y plus 6 equals 5, subtract 6, don't get y is equal to negative 1. So here's one answer, here's 2 answers. Now what do? Plug both of them into the first equation, right? So then you're going to take x, because I don't know it, minus 2 times, instead of y, we're putting in the negative 1, plus 3, and instead of z, we're putting in 2, equals 9. So do the math. X plus 2 plus 6 equals 9. X plus 8 equals 9. Doesn't x have to equal 1?
Miss Mary,
Yes.
can we plug it into one of the original equations, like the negative x?
No, I would plug it into here. You could. You could, but like on this one, the original equation here, this one was missing the z, so if all you had was z, you wouldn't want to plug it into here or
I
here.
know, but now that we have like y.
Oh, could you plug it into any of those? Yes, it should work. Yes. But I typically will do it here, just because it's easier math. Now, your answer must be written, and so your very last step, step 10, must be written as an ordered triple. This is in the 3rd dimensional quadrant. It's a quadrant that has an x-axis, a y-axis, and a z-axis. It's 3 dimensions. You can see it, touch it, and hold it. But it's very difficult to draw. Lucky you, I'm not going to make you draw it. And it does have to go in alphabetical order. So my x was 1, my y was negative 1, and my z is 2. If you don't write it in the ordered triple, you will lose points, because that is the correct answer. Now, if I were you and I were taking a test, I would check it in the original equations, not this one here. I would go back and check in all equations, plugging in the x, y, and z as needed, and check the left side to the right side. Does that make sense? Now, in your homework, you can throw it into your calculator and do it really quickly, right? And oh, by the way, there are ways to do these systems on your calculator. You will not be having a calculator on your test. Because couldn't you turn this into a matrix? And don't some of you know you can do matrices on your calculator? Oh, well, you can. It makes life so much happier, but you are not allowed to do it on your calculator, only because your college professor is expecting you to know how to do it by hand. Okay? All right, next one. Can I take that away, or are we still writing? That like took a whole page, right? And imagine if you make a mistake. Oh, I got to do it all over again. That's, well, I'm Mrs. Murray. All right, can I flip it?
Oh my goodness. Are all of these up on the page?
Uh-huh.
Are you
All right,
doing
so,
this in your
yes.
or-
So this next one is called a non-square system, gentlemen. So we need to know, what is a square system? So a square system means that the number of equations is equal to the number of variables. So in example 1, we had 3 equations and 3 unknowns. 3 by 3 is a square, isn't it? In this particular non-square system, we have 2 equations and 3 unknowns. A 2 by 3 is not a square, wouldn't you agree? So a non-square system just means that the number of equations differs from the number of variables. So here, you can see we have fewer equations than variables. So this is going to be equation number 1, and this is going to be number 2. You ready? Okay, step 1. Here we go, and you really want to know the process for this one. So your first step for this one is to rewrite the system in row echelon form. So a stair step, which implies sort of that we have a stair step. You'll see what I mean in a minute. Yeah, because you're like, I only have 2 equations. We're going to kind of create a third equation. All right, so if I want to do it in row echelon form, what do I want to do first? What's my first goal? Row echelon, what was your first goal on the last page? To get rid of your x's in all the columns in the first column except for one of them. Doesn't that one have a coefficient of 1? Okay, so that one has a coefficient of 2, so I want to multiply this one by something. What do I want to multiply it by? Negative 2. So I'm going to take negative 2 times x minus 2y plus z equals 2. Put a line under that, only because that's the only one we're changing. So we end up with negative 2x plus 4y minus 2z equals negative 4. Make sure your z's have a slash through them, otherwise they look like a 2. And then put your second equation right below that, 2x minus y, less on paper, more on paper, what am I thinking, less in your head, kill a tree. If you can free up your brain to think by putting it on paper, you're going to make less mistakes. That's my point. You can plant another tree. It's a renewable resource. As I said, in 18 years of teaching, no student group has ever planted a tree, so you really don't care about it all that much. Okay, you can't have the same human. You can have an equivalent tree. Yes, you can.
No, it's obviously.
Okay, I'm not going to get in this discussion right now. All right, so if I add these together, I get a positive 3y. I get a negative 3z equals a negative 3. Do I want a 3y? What's my goal in that second equation? This is supposed to be my new second equation, but can I have a 3y? No, I only want a y. So I have to keep going to manipulate it. The only way to get a y is to divide that by 3, but don't I have to divide every single term by 3? So that gets divided by 3. Unfortunately for you, they are all divisible by 3, otherwise you'd have some ugly fractions in there, but yes, you can have that. So I end up with y minus z is equal to negative 1. There's my new equation. So, step 2. Now we have our original first equation, x minus 2y plus z equals 2. We just created our new second equation, y minus z is equal to negative 1. That's what I mean by row echelon form. but we don't have a third equation. So here's what you're going to do. This is a big step, so I'm going to wait till you're ready. Is everybody ready? As ready as you'll ever be. Now we're going to work our way into a strange answer, because there are an infinite number of solutions to this non-square system. There always are. An infinite number. So here's how you're going to find it. Okay, so step 3. You are going to solve for y in equation 2, our new equation 2. And substitute that into equation number 1. You'll see why in a minute. Okay, so if I take this new second equation, y minus z equals -1, and I solve it for y, what do I have to do to both sides? Yeah, add a z. So don't I end up with y equals z minus 1? I'd rather write it as z minus 1 rather than -1 plus z. It's just awkward. So I'm going to take this right here, this value right here, and I'm going to plug that value in for the y in the first equation. Okay? So here's your first equation, x minus 2, and instead of y, we are replacing it with z minus 1. So we're using substitution into the other equation. Plus the z equals 2. So that's the original first equation. We plugged in what we came up with for the second equation that we solved for y into here. And the reason for that is I'm trying to get a z, correct? So now I've introduced, because if I look at these two, if I try to add these the way they are, won't my z's cancel out? And then I'm left with one equation and two unknowns, which isn't very helpful. So here I end up getting x minus 2z plus 2 plus z equals 2. And I'm sorry, my z's and 2's look alike. That's a 2. And I can keep going, can't I? What's 2 plus 2? Oh, that's a z, sorry. What's next? See, I can't even read my own handwriting. What's a negative 2z and a z? Negative z. And then don't I want to move the 2 over here? Oh, what happens? Yeah, so I get an x minus, because of this one, so I'm taking this one and adding together, so I get a minus z. I'm going to subtract 2 and subtract 2, don't I get equal 0? Wouldn't you agree that x is equal to z? If you solve for x, doesn't x equal z? So x and z are going to be the same number as what that says, in this case. Okay? It's a thought. So now here's what you're going to do. Step 4. Finally, so once you get down to this step, finally let z equal a. You'll see why in a minute. Let z equal a. We're going to create a pattern. Let z equal a. I know. No, not yet. Let z equal a where a is a real number. So it's not imaginary. You have the solutions. So if x is equal to z, and we're letting z equal a, what does x actually equal? A. Are you with me? Because x and z are the same number, we're letting z be a, and if x and z are the same number, then x is also a also, right? Okay. Do I have a way to find y if z is a? So what's y? Here's what y equals. What's y? A minus 1. So we have a, instead of a z, minus 1. And then, bless you, and then z also equals a, right? So this is what your triple order pair is going to look like. Can I move up? Because I have to move up to the other column. Can I move this away?
Yeah.
Nope, almost. Yep. All right, so then step 5, once we figure out what the pattern is, because this is the pattern to our infinitely many solutions. So step 5, so every ordered triple no. My computer's not allowed to go to sleep. Every time it sleeps, it won't load my movie onto YouTube. So every ordered triple, now I lost my train of thought. Every ordered triple is in the form so if x is a, we have a, comma. Michael. If y is a minus 1, then y would be a minus 1, comma. And then z is a, right? A minus 1, a. Every ordered triple for this system has to be in that pattern. So then you have to come up with several solutions. They might tell you let a equal 1, 2, 3, whatever. It could be a negative number too. Typically, you're going to choose 1, 2, and 3 if they don't tell you. So then step 6, you're going to come up with some possible solutions. So some example solutions might be we're going to let a equal 1. So in my triple, I end up with 1, because a is 1, comma, 1 minus 1, comma, 1. Right? All I did was replace the a with 1. 1 minus 1, 1, which the answer would be 1, 0, 1. Right? There's an example solution. But if I let a equal 2, right, we're going to have the pattern of 2, comma, 2 minus 1, comma, 2. All I did was replace the a's. So what's my little triple? 2, 1, 2. You let a equal 3. So don't you get 3, 2, 3? So what if a were 50? You'd have 50, 49, 50. I mean, so we could go on forever, right? I cannot emphasize enough to you that you've got to do your homework in order to practice this. How many examples did I give you? No. How many homework? Oh, okay, I gave you 2 examples. How many homework problems did I give you? 4. If you don't practice this, you're not going to have questions for me tomorrow, and you're not going to know where it is you're struggling. So make sure you do that homework.